Yeah, so I'm in Team Cassiopeia, and we've made a project involving like space. So it uses reinforcement learning, and it's called MarsNet RL, and it uses its reinforcement learning to know like what action to do next and what to not. And I'll move on to the problem statement, so you know what it's about. So in the future, like satellite networks will expand around Mars for planetary exploration and further data collection. So actually, our problem statement is a combination of two different problem statements, which one involves the congestion of satellites around Earth, and the other involves like how do we make rovers on Mars autonomous so they don't have to deal with a large communication delay. Like it's almost 20 minutes, and so our actual problem is how do we make satellites on Mars autonomous, and how do we make them make their own decisions? So, um, yeah, the ground control, like on Earth, can't manage the real time collision avoidance. So they have to be able to like do it by themselves. So there's no delay, otherwise they might hit each other. And what's happening on Earth is like it's already a big problem. Like there are almost 30,000 pieces of like space junk and satellites in total, and that's consisting of like 14,000 operating satellites and also like 20,000 other space junk like orbiting Earth. And there are large satellite constellations like SpaceX Starlink, which contribute to a lot of like satellites that are active right now. And so a lot of this doesn't even include like small objects like even space junk that's below 10 centimeters. And those can be like a problem, and those have to be considered when um, space entities decide to launch a rocket or a satellite to other planets. And these satellites serve different types of like roles, like communication, observing the planet, serving scientific research, and military applications. There's recently been like a big increase in these satellites. So from mid 2023 to early 2025, there's approximately a 30% increase in the number of satellites. So our solution is, of course, to automate the satellites on Mars so they don't have to deal with the communication delay. So if there's like in the future, there'll be like a lot of satellites sent to Mars to observe like what's happening on the surface and collect data, and that has to be sent back to Earth. But like since it's a constellation, they have to deal with not colliding with each other and other satellites, and they also have to worry about not colliding with space objects like asteroids or other space junk. And this is a good time to start this kind of project, we think, because like it's better to like solve the problem before it starts, like see how it's a problem on Earth. There are a lot of satellites that can't control themselves, so we have to keep track of them with radars and optical satellites. But if we can control like what gets sent to Mars before they're actually sent, then it'll be way easier to avoid collision. So we're building a system that trains a simulated constellation of satellites that looks like this, that autonomously adjust their orbits, avoid congestion, and also have to optimize communication coverage. So the reinforcement learning agent learns from points being added or deducted based on what it does. So if it strays too far from the target orbit it was given, there are points deducted, and points are also deducted for consuming too much fuel. So it has to conserve as much fuel as possible. And if I can just demonstrate the app right now, just give it a second. So yeah, this is the landing page of my project. It says MarsNet RL right there, and it just says Autonomous Martian Satellite Simulator. So I tried to make it like easy to understand for any users who are just seeing this and just easy to know what it's about. So to enter the actual app, you just press this button right here, try MarsNet console, and then you come to the actual app that I've made right here. So this is the main thing right here. It's the plot, and it takes a second to load in. Um, so this is probably pretty obvious, but this is Mars, right? And we've added the other satellites, which are its moons. Like those also count as satellites, and they have their own gravity. So the satellites have to consider those as well if they get too close. And these are the satellites and their orbits, right? All the orbits are just highlighted right there. You can change like the number of satellites, and if you change something, it'll say like applying changes. So before you like animate the satellites, you have to, wait until that's finished. You can change the number of satellites, you can change the mass, which we estimate like different masses of satellites will be sent, like up to maybe 1,000 kilograms. And that can definitely change like how much fuel the satellite will use. So that's important to consider. And you can also change the density of debris, which include like anything from small asteroids or space junk. And I don't know if you know, but where Mars is located, it's located in between, or no, in between Mars and Jupiter, there's the asteroid belt, which there's just a lot of asteroids there. So Mars is constantly hit with asteroids, and its atmosphere is not as dense as Earth's, so it is hit a lot. And here you can control like how large the orbit is. By default, it's 1,000 kilometers, but it can go all the way up to 17,000. And I've included this because at this point, when satellites are this far away from Mars, which is 17,000 kilometers, it's like aerial stationary, which means if you are on a point on Mars and you look in a direction and the satellite's there, it will always be there because its speed matches the rotation of Mars. And this will be really useful in the future where like there might be ground stations set up or rovers and facilitate communication between the satellites and those ground stations. Um, this checkbox right here is to enable the training mode. So this means that reinforcement learning will be actually used. And then you might have seen like some of the satellites, which are indicated by these diamond shapes right here, change to red and green. So red just means if it's going down or up. So green means it's going up. And that's what the RL agent plans to do with the satellite. And I'm just going to increase the delay between frames right here and go all the way up to half a second before I just play what's happening. And it's just taking a little bit to apply the changes. And I included the delay because they obviously they may change their behavior. So yeah, you see the satellites change colors between green and red, which means it's changing like whether it's going up or down. That's what the RL agent is choosing to do. And if you remember, I said if it gets too far away from the orbit, um, points are deducted. So it tries to stay as close to the orbit as possible. Um, so this is a little bit of an issue right now. We plan to make it like less laggy. You just have to wait a little bit before you actually animate this. Otherwise, it'll just mess up a little bit. So that's what we plan to do. That's what I plan to do. And down here, you can see the data of each satellite. So you can see how many times it has collided, and this completely matches up with however many satellites there are. So you can see the data of each individual one, and also how much fuel it has used. And then finally here is the logs for RL training. So this is like how much points it expected to receive from its actions, and the orange line is how much it actually received. And so it should be stable or going up after a while. So at the end here, it's just kind of increased here, which means it's learning. Um, and apart from that, yeah, there's this assistant, and it can help you with like whatever you want to do, any missions in the future. And this can just be useful for space agencies, or this type of like anything like this would be useful for any space agency planning to launch satellites to Mars. So yeah, that's our app. Right, and that's kind of all for me. So yeah, thank you.
Yeah, hi. So yeah, it was a good presentation, and also